Integration by parts is section 7.2. It covers a new integration technique and method. So to review old methods of integration, number one is do you know the integral right off the bat? Do you know how to integrate that without doing any real work? Does it come from an old derivative? Does it follow basic integration formats and rules? Number two would be an algebraic manipulation. If, for instance, in all of section 7.1, we found some algebraic way to manipulate it so that it can be something we know and or, again, use for the final result is U sub. So now we have three rules to follow. Do you know it? Does it require some algebra before we get to do we know it? And then is there a U sub that we can use? Now remember, U sub kind of comes from the chain rule of derivatives. Okay, in terms of the chain rule, it was a function inside of a function, and again, that's kind of how U subs work. It's identify the interior function and let U be the interior. Integration by parts, however, follows a different set of rules, and it actually follows, let's review your old derivative rules. The derivative ddx of, say, f of x times g of x, the product, is the same thing as the derivative of the first times the second, left unchanged, plus the derivative of the second, g prime, times the first, left unchanged. Now, in looking at this particular example, we can manipulate this ever so slightly. So what I'm going to do is I'm going to go ahead and start by integrating both sides. So I'm going to integrate this side over here. So it's the integral of the derivative of this stuff, f of x times g of x. And then I'm going to integrate this side over here. So f prime of x times g of x plus g prime of x times f of x. And don't forget, again, right on the end here, we're going to tack on that dx. And in here, we're going to tack on that dx. So what's nice about this side over here is that if we're integrating the derivative, we end up just getting back the original functions we had. So this side here is just f of x times g of x. This side, however, over here is not as nice. So what I'm going to do is I'm going to go ahead and tear apart this integral so that it's viewed as two separate pieces. So it's the integral of f prime of x g of x dx plus the integral of g prime of x times f of x dx. Now, with this being viewed, we come to problems in terms of the functions, and I think they just get very convoluted very quickly using this particular format. So if we can go all the way back to the beginning up here, instead of using f and g, let's identify f as the function u and g as the function v. Now you'll notice here I'm going to go ahead and make sure my u has the tail on the end of it here, and my v I'm going to go ahead and make sure it has a flat vertical line, or sorry, horizontal line coming off the end as a tail, so you can tell the difference between my u's and my v's. So down here, f ends up becoming u, my g becomes v, and this is equal to, over here, the integral of, it looks like, well, your f prime, which is theoretically just going to be u prime, okay? And then your g is still going to be that v function. And that's all in terms of dx. Now, dx causes problems for us. We don't really like dx, so what we're going to do is we're going to identify that u prime, if f is a function of x, then if I'm looking at u and trying to take the derivative of u, du is actually going to be some formulation of dx with that u. Don't forget, again, if we take the derivative of u, it's going to be u prime with a dx. So what we're going to do is we're going to have that dx get absorbed. Again, maybe it's better to view this thing right here, not as du equals dx, but that u prime is the same thing as du over dx. In which case, du and dx, I can go ahead and replace this u prime with du over dx, and watch this dx cancel out with this dx, providing me with the integral of v with just a du left over, because again, this u prime is du dx, and the dx's cancel out. I'm going to do the same thing over here with this integral. So my g prime of x is the same thing as the derivative of v in respect to x, so it's going to be dv dx instead of du dx. So this is the integral of dv dx times u, because again, f of x is just u, and then times dx. But you'll notice, again, the dx's cancel out, and that leaves me with the plus the integral of u dv. Yes, this is algebra of your differentials. Again, not the derivatives, but the differentials that make up those derivatives. We normally are not allowed to do this, but in this case, it's completely fine. So now you'll see that we have this u times v is equal to the integral of v du plus the integral of u dv. So what we're going to do to make our formula, and again, this might seem just out of nowhere, but this is the formula that we're going to use. I'm going to go ahead and shift this integral to the other side, and then have this integral by itself. So the integral of u dv is equal to the integral, let me start with the positive terms, u times v minus the integral of v du. So this is the rule for the integration by parts, and this is the rule that we're actually going to use in the next couple of videos. Keep in mind, we're going to identify u as a function, we're going to identify dv as a different function, and then we're going to be able to manipulate those two functions in a way so that we end up with all of the pieces on this side. And this is the part that we've integrated. Again, it's called integration by parts because we've used this formula to integrate a part of it. A part of that is now outside of the integral. And then we have this secondary integral that we should be able to easily evaluate. So this adds a fourth step, and again, this fourth step for int by parts really comes from if you have the multiplication of two different functions, f and g. Again, if you have two different types of functions.